There was a time in Earth's history when the land turned lethal. Forests vanished, oxygen disappeared, and the only place left to hide was underwater. This isn't science fiction. It really happened. And today, you'll hear the true story of the only moment in history when water was safer than land. It happened 252 million years ago, in a world that bore little resemblance to the one we know today. Back then, the continents had not yet drifted apart. They were fused into one vast supercontinent called Pangaea, a single, uninterrupted landmass stretching from pole to pole, surrounded by a global ocean named Panthalassa. Life on Earth had been thriving. Evolution had unfolded over hundreds of millions of years, crafting dense forests filled with towering seed ferns and populating the seas with coral reefs, ammonites, and armored fish. On land, the ancestors of mammals and reptiles roamed a landscape teeming with species now lost to time. This was the late Permian, a moment of flourishing life and planetary balance. But beneath that balance, something was shifting. Far below the surface, deep in the crust beneath what we now call Siberia, the Earth's mantle stirred. Immense plumes of magma forced their way upward, cracking the crust open across thousands of square kilometers. What followed was not a single eruption, but an era of relentless volcanic activity that spanned nearly a million years. Lava spilled across the land in waves, covering millions of square miles. These eruptions created what scientists now call the Siberian Traps, one of the largest and most prolonged volcanic events in the planet's entire history. But it wasn't the lava itself that would reshape the future of life. It was what came with it. As these supervolcanoes erupted, they spewed colossal amounts of gases into the atmosphere: carbon dioxide, methane, sulfur dioxide, and more. The greenhouse effect these gases triggered was immense. Global temperatures began to climb at a pace life was not equipped to handle. At first, it was subtle, but as the years passed, the shift accelerated. Some estimates suggest the average global temperature rose by as much as 10 to 15 degrees Celsius. The land dried out, rain became acidic. Forests that had stood for millennia began to decay and collapse. Plants withered under the changing chemistry of the air and soil. Insects, which had long endured countless climate shifts, began to vanish from the fossil record. Oxygen levels in the atmosphere fell to levels far lower than what modern animals need to survive. Breathing became more difficult. The large vertebrates of the time, unable to adapt quickly enough, perished one by one. The fossil record, once full of tracks and bones, becomes eerily quiet during this period. Forests disappear from pollen samples. Soils lose their organic content. The land had become hostile, overheated, unstable, and depleted. And while these surface changes were devastating, the oceans were undergoing a transformation just as severe. As carbon dioxide continued to build in the atmosphere, more of it dissolved into the sea. This made the oceans more acidic, corrosive to shells, reefs, and delicate marine organisms. At the same time, warming seas began to lose oxygen. Warmer water holds less dissolved gas, and without oxygen, life in the sea began to die. But the consequences didn't stop there. With less oxygen near the surface, the deeper layers of the ocean stagnated. In this still, suffocating environment, sulfur-loving bacteria flourished. These microbes began producing hydrogen sulfide gas, a compound toxic to nearly all multicellular life. Some of it remained in the water. Some likely escaped into the atmosphere, further poisoning the land. As this gas spread, it contributed to the collapse of entire ecosystems, both marine and terrestrial. In the shallow seas, coral reefs disintegrated. Fish populations collapsed. Trilobites, resilient survivors of earlier mass extinctions, finally disappeared forever. The ocean floor, once alive with sponges and invertebrates, became barren. What remained were only the simplest forms of life, those capable of enduring in anoxic, acidic waters where little else could survive. By the time the cataclysm reached its peak, an estimated 90% of all marine species had vanished. On land, over 70% of vertebrate species were gone. It was not a single blow, but a slow unspooling, a long, grim descent into silence. And yet, even in that silence, something endured. Far below the surface, in deep, cold pockets of the ocean where oxygen still lingered, life held on. Not in abundance, not in beauty, but in persistence. Simple fish, microscopic plankton, and a few scattered shelled animals continued to survive, drifting through murky water, feeding on what little remained. These were the last embers of a world that had nearly gone dark. For the only time in the planet's long history, the sea had become the last place capable of sustaining life. The land was scorched. The skies were no longer breathable. Forests had turned to ash, and the air carried heat and poison. But the deep ocean, with its stable temperatures and slow currents, became the final refuge. As the extinction deepened, Earth's systems remained in collapse. Oxygen levels in the oceans stayed dangerously low. Warm surface water formed a thick barrier, trapping stagnant, lifeless water below. Circulation slowed to a halt. This disrupted not only marine biodiversity, but also the core processes that had stabilized the oceans for hundreds of millions of years. Coral reefs remained absent. Filter feeders vanished. Food webs, once layered and complex, had been reduced to basic chains of survival. With little oxygen, few nutrients, and chemical imbalance, entire regions of the ocean became inhospitable to nearly everything. On land, the picture was equally grim. Where ancient forests once grew, fossil evidence reveals a sudden absence of plant diversity. There is no record of complex forest ecosystems for millions of years after the extinction. Insects, typically resilient through previous extinction events, experienced their most significant collapse in Earth's history. The land had not only emptied of large animals, it had lost its foundational life forms as well. It took over 5 million years for the Earth to begin showing signs of large-scale ecological recovery. During that time, life remained sparse and fragile. But even through those barren ages, the process of rebuilding had already begun. In the ocean, a new group of marine organisms gradually expanded. Bivalves, ammonoids, and the early ancestors of modern fish. The reappearance of reef-building corals, though slow, signaled a shift toward more stable conditions. On land, hardy plants capable of surviving in poor soils and thin air spread across degraded landscapes, creating the first new vegetation since the collapse. These plants helped capture carbon, stabilize soils, and pave the way for herbivores to return. The Triassic period, which followed the Permian, began as a blank slate. The extinction had cleared nearly all dominant life forms, making room for new evolutionary experiments. Early archosaurs, distant ancestors of crocodiles and birds, emerged in scattered environments. Some synapsids, relatives of mammals, also survived and slowly adapted to the changing climate. Though these species were few and scattered, they laid the foundation for entirely new ecosystems. This reset would eventually lead to the rise of the dinosaurs. Over tens of millions of years, they would spread across the continents, filling the gaps left by extinct species. In the oceans, large marine reptiles appeared for the first time. Ichthyosaurs, plesiosaurs, and others, descended from the small survivors of the Permian collapse. The diversity of life returned not in the same form, but in new ones, built from the remnants that had endured. Today, the story of that extinction is preserved in stone. In South China, geologists have uncovered deep-sea sediments layered with organic matter. Dark shale formed during a time when oxygen had vanished from the water column. In the rocks of Italy and Greenland, sudden shifts in carbon isotopes reveal a massive injection of carbon into the atmosphere. And across multiple continents, fossil records show a steep, unmistakable loss of life, followed by millions of years of stagnation. Scientists studying these patterns have confirmed that the Great Dying was not caused by a single event. 'Twas a chain reaction triggered by volcanic activity, accelerated by greenhouse gases, and amplified by ecological collapse. What makes this extinction especially important is not just its scale, but its mechanisms. The combination of warming, ocean acidification, loss of oxygen, and widespread habitat destruction mirrors some of the challenges the modern world now faces, though the source is different. Today, it's industrial, not volcanic. The processes unfolding now are scientifically comparable in many ways. Carbon dioxide levels are rising. Global temperatures are increasing. Coral reefs are bleaching and dying. Some parts of the ocean are already developing low-oxygen dead zones. While the scale is not yet the same, the trajectory is similar. The past is not just distant, it is predictive. But this story is more than a warning. It's also a record of resilience. Even in conditions that seemed entirely uninhabitable, life endured. Not because it was strong, but because it adapted. Some organisms retreated to deep-sea environments. Others survived in isolated regions where the worst effects were delayed or diminished. They lived not because conditions were safe, but because they were just survivable enough, and that was all it took. From those few survivors came every lineage we know today. Mammals, reptiles, birds, and fish all descend from the life that made it through the Permian-Triassic boundary. The entire evolutionary tree of modern life is rooted in that narrow, brutal window of survival. There is no moment in Earth's history that compares to it. In every other mass extinction, life continued in pockets across the land and sea. But during the Great Dying, the scale of devastation was so complete that even the basic functions of the biosphere nearly ceased. It was the only time land became a greater threat than ocean. Not because the sea was safe, but because the alternative was worse. The surface of the Earth itself had turned against life. And yet, Earth recovered. Slowly, painfully, but completely. The story of the Great Dying is the story of collapse and transformation. It is a reminder that life on this planet has faced total ruin and that it survived. It is not a narrative of triumph, but of endurance, of holding on in the most unlikely conditions, of change, not return. There has only been one time in Earth's history when land failed life, and the deep ocean, oxygen-starved, acidic, and nearly silent, became the last viable refuge. If you want to hear more true stories like this, silent, buried, but entirely real, subscribe to the channel. And let us know what chapter of Earth's forgotten past we should explore next.